Actually, I'm taking prerogative of session chair and inviting everybody to stand up, move around, stretch, and do all those other important things for about 3 minutes while we get the next talk up. But I would really like you to come back so you can hear some of the technical kinds of approaches to dealing with this data. Okay, 3 whole minutes, folks. Okay, since everybody came back in a nice, timely manner, it's our turn to stay on target for the timing, so you actually get to eat some lunch. The 2 talks that we're going to have are going to talk about some technologies that various researchers have developed for dealing with different kinds of data, specifically image data, et cetera, et cetera. The first speaker's Peter Bajcsy, who I've supported in the past that I know of, who has done multivariate data in various kinds of situations, looked at common image pre-processing and analysis tools. And both he and the second speaker, Richard Marciano, are joined by a very deep interest both in the preservation of data, but also, and its archiving and ways of accessing it, and also of issues about how to continue to do this. In most instances, one of the purposes is to actually make what is possible transparent, the thing that Vernon spoke about, that is, making it so you didn't have to worry about what was under the hood, but ensuring that what was under the hood was reliable and appropriate. Anyway, Peter, you have 22 minutes.
Okay. 1, 2. No, this one doesn't. Okay. So I was just looking for those 3 crosses here. So when you watch America's Got Talent, you know where you should be standing in front of the camera, because I have my automated slide flipper, and then that means that I'm going to be walking back and forth. The main topic or main theme of my talk today is really automation. I am coming from the computer science background, so I'll pose right at the beginning of my talk a basic challenge for all of you. How many of you would be ambitious enough to publish the first research paper in genealogy, urban sociology, architecture? Okay, thank you. On April 3rd, 2012, right? So that's the challenge that you have. How many of you would like to do that, right? Maybe you cannot do it on April 3rd, maybe on April 5th. But the question is there any technology out there that could help you? And pretty much you could even maybe go to different conferences and find different challenges. Like, you could pose a challenge, I was jotting down here, show all John Smith families in 1940 census on a Google map, right? That would be a very simple, thank you. So if the automation technologies that I'll show excite you, please talk to me and I'll show you some online solutions or some solutions that we have developed in our group. Okay. So here is an outline of my talk, and I'm going to primarily focus on that pipeline. How do you go from raw images to searchable information? And kind of I put there some sub-bullets that really reflect my thinking, and probably if we had someone from Ancestry.com, they would be telling you how they are doing these steps. And then because I didn't really get too much input before the workshop, what I'm supposed to talk about, I kind of summarized some open problems for the sponsors so they know where they might invest money and what the open research problems are. Okay, so introduction. I want to give credit to Finette and Martin because they provided the information about the master copies. I am a computer scientist. I really care about how many files I have to deal with, what is the volume, how much computational resources I have to have for that, and can I automate it? You've seen already this information. So then I went online and I was looking for information that are additional data sets that are currently available, which is the federal census form. And then I also found some forms that were slightly different, so I didn't know why these 2 forms were different. But the quality was pretty good. I would say that you can read that. There is a little bit of blur here if you look at it and if you digitize it, but I assume that that comes just from the low quality of the microfilm or the original paper copy. And then when you go online, you can find companies that have digitized many of the federal census records, provide subscription-based services, and they claim, based on my reading, that this is all based on 407 million name searchable database. So that's pretty large size. So our question is, how can we automate the pipeline from imaging of census paper documents, or actually now they are microfilms, to searchable digital information? So if you think about what you would like to do if you were given this task, you would like to maximize the automation of processing and accuracy of all the extracted information and minimize your cost and processing time. And our goal is really to understand what existing technologies and expertise could be used for meeting these objectives. And in order to convince you that I did my homework, I downloaded some raw images of 1930 census data, about 5.7 megabytes per file. And because I live in Champaign County, I downloaded the files for Illinois, Champaign County. So this is the quality of those images. And you can see that some of them are okay. The edges are a little bit torn, which can create some problems. And then you can see here, I think I have a laser pointer here somewhere. You can see here that there is an empty spot and that information might be missing. Otherwise, you can make observations that there was a scribe who probably was pretty consistent. You can see that the word Illinois is very consistent. Some entries have only categorical variables, yes, no, male, female, which is very good for automated analyses. Some entries like names are probably very hard to recognize because they vary a lot. Okay, so if you think about the pipeline from raw images to searchable information, you first probably would like to take the forms that were given, the blank forms, and somehow detect them in your microfilm image. And then once you know exactly where the fields are, then you go and then you extract or segment out those fields like I did with the word sun. Now, you have just an image, then you want to really know that that image represents sun, so you have to do some form entry recognition. And then once you extract that information, you have to somehow manage. You have to know that that particular entry, the string, sun, came from a form, let's say for Champaign County, and it was associated with the name and address and so forth. And eventually you want to make it accessible, available on the web, right? So that's the web-based presentation and access. And then let people do their scholarly research and perhaps integrate it with additional information, right? Because you have other sources of information. Perhaps you can put a layer, another layer with historical maps, and you will show where that person lived and how that landscape looked at that time. Clearly, there will be some steps that you need some manual intervention because the algorithms are not good enough. So let's look at the level of automation. So let's look at the form detection and segmentation. There are two basic approaches that I can show. One is template-based, and the other one is border detection-based approach. So I took some of our tools, and I took the form. This is actually downloaded from Ancestry.com. I took one of the 1930 forms. And use one of our tools that we developed where you more or less click, select the points, and I selected the corner points, and you can see on the left side and on the right side, I matched the red and blue dots, and I applied affine transformation, which gives you rotation and translation, so now I can overlay them. And when I change the transparency, you can see that the form doesn't actually match the underlying, the scan. Although the corner points match accurately, you can see that I matched them, I think it's right here, right? They were matched very accurately. The ratio is not correct, so now I don't know whether Ancestry.com didn't provide the right form or there are multiple templates, but that's something for the automation, which is very important because once you register that, you want to be able to go, and now I know exactly that this region or this region has names, this region has relationship, and so forth. Okay, we have done something similar in the past. There was a project, you might not know, but Illinois is the fattest state. So we were tasked to look at some documents that your kids, or you actually, you as parents, fill out when your kids enter school. And based on that information, we could derive a BMI, body mass index, and we would be analyzing these DM, Department of Human Service paper forms. They were scanned, they have front page and back page, and again, we are trying to fit the template. And unfortunately for them, these forms are faxed, they are scanned, there are all kinds of distortions, and they are manually filled. You can see that the answer yes and no has a lot of inconsistencies. So why I'm showing that? Because we have developed some algorithms that can match the template to the original scan, but there are some key aspects that probably those people that deal with these documents should consider. One is the scanning quality, and one is the consistency of forms. The other approach is to look at the boundary. I'm just showing another related work that we have done. We are looking at fully automated scale estimation of historical maps. And this is based on the neat lines. If you recall, there are these borders, and they have latitude, longitude intersections. This is a project funded by NSF, NNEH, and JISC in UK. And we have these maps that are huge, and we first try to find exactly the border of the map, and then we can analyze the neat lines. But from the census, 1940 census perspective, you could approach the problem by just identifying the border of each form, and then you know exactly where the fields are. You can see here that the key aspects here would be consistency of the background. Many times the census forms might be, I don't know, whether the quality of the paper was degraded, so I don't know how to compensate for that right now, but you have to make sure that, let's say, when you are placing the paper form on a scanner, that the background is always the same. No matter what you do, I think consistency is critical for automation. There are questions about degradation of map background color. Warping of maps is an issue, because if you have a scan that kind of shows this curvature, another one is straight, then the automation has challenges. I mean, it's really hard to design an automated method to compensate for that. Okay, so now I took the form, which was the original, and I can easily segment it, and I know now the green and blue squares or rectangles are really my fields, and it's registered, so I can go to the form and carve out many instances of the word sun. So now I have many of these small images. I look at them, I see that they are all sun, but I have to somehow understand whether I should carve out just that square or I should square much more, because let's say in the word daughter, you can see that the G is going to go below the line. And then the question is, the key aspect there is what should be the extent of the cropped image in order to do the handwritten character recognition. So there are some interesting issues, research issues. How would you even go about segmenting that form so you generate a bunch of these images that can be passed to your character recognition system. And you can see that the word daughter varies much more than the word son. Okay, so now I have segmented the form. I matched the form, I segmented the individual entries. Now I want to do the recognition. People have mentioned OCR and so forth. There is a difference between printed character recognition and handwritten character recognition. And actually what we are even going to propose is that we shouldn't even know, we are not really doing every character recognition. Perhaps if the word Illinois is so consistently written, I can just train my system to say, oh, this is Illinois. So just look at the pixels compared to another image. And if I see that the pixels are similar, I know that it's Illinois. I don't have to do the recognition of I, L, L, I, and I. Okay. So let's look at the form entry recognition. What I would like to do is associate my entries that I just extracted, head, son, daughter, with the string head, son, daughter, right? So those are my training samples. And now I'm going to use this is called a supervised approach because I'm supervising the algorithm. And now I have a system that we developed where I can drag and drop my images, and then I say select these images and select comparison method, because there are many ways how you can compare two images. And then the result, you eventually compare and you will get some score. How similar are these images? And because you already labeled that image, well, this is son, this is head, this is daughter, now I know that, let's say, out of these would be, let's say, 2 daughters, 2 sons, and 2 heads. Right, so that's the way how it would work, and we have designed it. We have been sponsored by the National Archives to develop a content-based file-to-file comparison that we have been building, and this is all web accessible. Okay, then we have done some related work. We are involved in the 18th Connect project and the 19th Century Electronic Scholarship project. And these are documents that are printed, but they have all these special characters that nobody can really recognize, and therefore commercial solutions like developed by Abby would not work. You really have to customize that. We actually did a study, and you can find online an article about it, how much computational power you will need, and how difficult it is to customize commercial software. But Gail had already created 138,000 digital image files. So we are looking at solution, and I'll show a preliminary solution. More or less, if this movie had worked, you would see, and I think I can probably quickly do that just to show what I mean. So pretty much you go, you drag and drop your file. Here is your TIFF file, which is one of the manuscripts. And then students before us develop or use Gamera, which is a software where you identify an image region and you associate it with a label. As you drag and drop that file, we automatically extract any metadata embedded in the image, and we automatically start a certain computation on the back end. So we create immediately the pyramid, so the image can be zoomed in and zoomed out. There is a pyramid for a very large image viewing. And the stage 3 will immediately launch the handwritten character recognition based on Gamera. Right, so I can go, and now I can look at the result, and my result is going to be the OCR result. Here is the OCR result. Perhaps it's not perfect, but I can go and edit it, right? And that happens as soon as you drag and drop your file to the system. All the computation is happening on the back end. You see I build a pyramid, so now I can zoom in and zoom out. On the right side, I can tag it. I can add it to a collection. And also what is critical is to keep provenance. So I know that this particular result, the OCR result, the string, came from that image. So that relationship is preserved. Okay, going back to what we could do. So key aspects here, we use Gamera, which is open source code, and we created training images, training samples. The question is computation scalability. I think we did an estimate for the 18th Connect project. It would cost them about $250,000 if they had paid Abby. And then it was about the same amount of money. I think they were looking at 1 million pages to OCR. It would cost them probably a similar amount of money if they had students doing that. And as I said, the key aspect here is to keep the provenance trail. So you know which software you use, with what settings. Okay, we have also been involved in a work funded by the National Archives to look at automated extraction of handwritten and printed information from engineering drawings. This is related to the previous speaker. Here you can see that you would like to take the title block and the reference block, apply some optical character recognition, and then extract all the information, build a database so you can search. Our task was actually to relate 3D CAD models or those files with the 2D engineering drawings. What we have learned is that there are several templates, which is really going to increase your search space, because now I don't really know whether it's the template 1 or template 2 that I should be matching against the image. So that increases computation requirements. The other challenge there is that you see a combination of handwritten and printed text. So when we applied Abby, it would take, it would be performing well with the printed characters, but not well with the handwritten. And the question is also how to organize the information. Okay, I have to move to the next part, which is once you extract the information, what are you going to do with it? How are you going to organize it? How are you going to make it available, accessible? So again, as I was showing before, you can upload and automatically extract metadata. You can do all kinds of operations over those collections. Like here, you can create a collection, add metadata, add to collection, remove, and so forth. But you can also do operations like add user-defined metadata. Here we can add title, bibliographic citation, copyrights, language, publisher, and so forth. So you can always enter whatever you need to. And then there's also some social networking kind of option that you can like the image. You don't have to like the image. But what was really useful when we use historical maps, about 6 megabytes and very large pixel size. Here again, I could show the zoom in and zoom out capability. What was already brought up before, that if you could assign latitude, longitude based on the fact that this is Champaign County, if I would know that that's a Champaign County, I can immediately plot it on a Google map. And we are doing that right now with any photos that we get from contemporary cameras, because your camera will have the GPS built in. So when you give me the image, the latitude, longitude information is embedded there, and then we automatically extract it. And then as you drag and drop the file to the system, you see the location. And the other thing was the provenance information. You can see that this particular sub-area was extracted from this image, and it's already shown to the end user. Finally, you would like to kind of make it friendly for the end users. So we have worked on the project, automated cropping of handwritten Lincoln papers. You can see I said at the beginning that consistency is very important. These files, some of them are scanned at the National Archives, some of them are scanned at different museums. The Kodak color bar, which is to preserve the color property, was not placed consistently, and also for the web dissemination, you want to always crop it. So currently there are people who have PhD in history who were cropping them manually, but we designed algorithms that could crop the paper part automatically and then put it on the web. How would you deliver that on the web? Well, clearly you want to relay the time, or more or less the temporal part with the spatial part, with images and songs. Again, if this had worked, then I would have a music, because what we have done is more or less you can go there, search, and then it will show you all the documents that Lincoln wrote in that location and the time, and then we also give you transcription services. Okay, summary. So I have shown some computer-assisted approaches to automation of 1940 census data dissemination and the pipeline, and there are several problems that are similar to the problems in other domains. And there are good things and bad things about it, because if they have been tackled in the past, perhaps this community could reuse the results and solutions and adapt them to 1940 census. There are some cons, and the fact is, and we have to kind of live with it, the automation will never lead to 100% accuracy. And therefore, you have to have some manual input in the process. The other issue is that eventually you will need to build system that will combine the fully automated and semi-automated processing steps. So you will need human in the loop. And then finally, this is kind of, I'm advocating that you could use this kind of a citizen science approach. There are many high school kids that would love to contribute. They could transcribe documents, so perhaps that could be used. And then here are some open problems, just to understand what we should understand is the level of automation, accuracy of extracted information, computational scalability, and the cost. And there are additional things to kind of consider. So I put that additional notes for those of you that are interested, let's say, commercial solutions. There are a bunch of project references that I kind of used in the presentation. And then there are acknowledgements. Thank you very much.
All right, and our second speaker is Richard Marciano. And again, one of the things that Richard brings to the table is a concern with sustainability, which is another one of my hobby horses, although I don't expect you're going to talk about it much today, since there's a government in back of this stuff.
Can you hear me well enough? So my job is to ease you into the lunch period. So I actually have quite a few visuals here. I'm going to talk about, this is almost a case study. I'm going to talk about a specific project called T-Races, which was funded by IMLS, Institute for Museum Library Services. And I just put that online a couple of months ago. This stands for, it's a mouthful, Testbed for the Redlining Archives of California's Exclusionary Spaces. So this is actually, not sure how to call this, maybe a tweener or an in-between presentation. The period I'm going to talk about, the historical period and the digital archive I created, and I'm going to show you some of the tools I developed and flirted with. Some of these tools might be applicable to dissemination, searching of 1940 census, 1930 census, but certainly this project would benefit from actually incorporating all the 1930, 1940 information. So a little bit of background. The digital archive I created is actually based on records from the National Archives in the civilian records. It's record group 195, records of the Federal Home Loan Bank, Homeowners Loan Corporation. These happen to be city survey files from the 1930s, between 1935 and 1940. So I think this presentation will be relevant and connects with all these different themes, but it's kind of a particular slice in space and time. In some sense, this connects very nicely with an earlier presentation, like John Logan on urban transition historical project, in the sense that it sort of completes, it's the period after the 1920s, so you could really learn a lot by grounding it in all these earlier studies. So let's jump into the presentation. All right, just a little bit of background. I'm not going to talk about sustainability, but I'll throw it up in the beginning. I recently created a lab at the University of North Carolina, Chapel Hill, called SALT, Sustainable Archives and Leveraging Technologies. What this is really based on is cyber infrastructure developments. There's quite a bit of funding from NSF and other agencies. This little drawing is actually the kind of the symbol or the mascot. It frames sort of the conceptual approach of this lab we've developed. This is the ancient Chinese pictograph of salt. And what you have in there, if you break it down into its core subwords, you have in the middle, you have the grain of salt. So that's the content of the collections. Down here you have the vessel that was used to heat the brine to extract the salt. That's kind of symbolic. It's a metaphor for most of the projects I'm working on for infrastructure. And then the group I'm in is actually developing all kinds of innovative methods that have to do with policy, automation of processing, and its policy, so-called policy-based frameworks. So what you have here is the whip, which is a technique that's rather effective, but not always optimal. And what you have on the governance side is the head and shoulders of an imperial Chinese officer. So what you essentially see here, and this is my metaphor for digital preservation. It's salt as in a process of curing and preserving, which is still used. And what you really see here is that preservation is neither infrastructure nor content, but really a combination of activities. It's really a process. It's a manufacturing process. It's a governance process. It's based on, historically it was based on tax collection, enforcing policies, and all these different things. So the particular lab I'm in looks at sort of holistically the combination of all these different factors. And indeed, we have research projects that fall in all of these different categories. One more little piece of background before I jump in. As I was thinking about this presentation, I was actually reminded that almost a decade ago, in 1999, when my group was working with the National Archives, this was pre-ERA, certainly pre-NCAST. One of the case studies I was actually involved with was looking at the potential for long-term digital preservation of Tiger Line data. We looked at Tiger Line 92 and started thinking about the implications of dealing with census data in the context of these infrastructure and cyber infrastructure projects. So a couple of projects that are notable. I'm working on an NHPRC funded project called DCAPE, and this is building a trusted digital repository to actually bring in digital assets, such as the collection I'll talk about today, and disseminate it, and keep it, and preserve it, and so it speaks to services, preservation services, but also to life cycle issues of electronic records. And finally, I'm very pleased to announce and very honored to be part of the next round of funding of NCAST. Peter and I are both have been research partners of the ERA research component, and I have a project that officially starts in a couple of days that was just funded through NSF OCI called CYBER, which stands for Cyber Infrastructure for Billions of Electronic Records. So the motto is, we serve billions. And this very much relates to Peter's presentation, because we're going to be looking at visualization. So what happens when you have millions, hundreds of millions, going towards billions of records, and essentially everything breaks. And you need to automate as much of it as possible. So it's looking at visual frameworks for browsing, analyzing lots and lots of records. And it speaks to the process of building such collections in a distributed and federated fashion. It also touches on issues of computation, when you're doing indexing, when you're doing segmentation and OCR processes such as Peter's. You're potentially consuming a lot of resources. And it also speaks to a third topic, which is figuring, in the process of automating all these things, we're looking at formulating essentially policies and rules that can be executed automatically on these collections. So there's a whole policy framework component. All right, let me bring this in. So this is the context of this. How many of you are familiar with history of redlining? Okay, so quite a few people here. So I'm going to skip over the preliminary slides, and I'll show you some of the interfaces and tools we've developed. So just a little bit of very brief context. The redlining, the term redlining actually comes from these city surveys. These were conducted by the Homeowners Loan Corporation, which was a New Deal agency created in the 30s to look at the collapse of the real estate market and mortgage industry, construction business. What HOLC is credited for is streamlining the mortgage processes, doing really innovative things that had never been done before. In my view, their main innovation was to look at the neighborhood as a unit of analysis for denying or making loans. And this was very innovative. They also established 25-year amortized loans, essentially came up with systematic processes to both characterize cities, but also individuals, ethnic groups. So it's a whole valuation process that has to do with space and race and the allocation of mortgages. So confidential security reports were created. Field agents were essentially sent all over the country. The National Archives has some 200 and, I forget the number, 30 plus city files that were surveyed between 1935 and 1940. This was a map I created a few years back, just based on a paper index, approximate map. And what I did in this study is I focused on a particular region, so California. So we took all the cities of California and created a regional testbed. So this is part of the interface. The goal was really to make all this information available for researchers, historians, community activists, and some cities have been very well studied, but for the large part, a lot of these cities have never really reached the general public. And they are a treasure trove of information related to housing, construction, ethnicity, possibly migration, etc. So here's an excerpt. This is part of the interface we actually developed. The interface was meant to go beyond just producing images, which is really the theme, part of the theme of today's conference, and seeing sort of what aspects of visual analytics or tools we could create on top of that to facilitate the indexing, searching, correlation between different documents, etc. So on the left, you'll see a little menu. You can choose your favorite city. In this particular case, I picked Los Angeles. And then there's a little tools menu where, in this particular instance, I chose just a browsing of the image files themselves. So the image files are segmented into different categories. You have summaries, the survey itself, which is kind of an economic, mortgage, housing, ethnic survey. In some instances, like Los Angeles, you have a resurvey. The area descriptions, which is what I'm going to talk about. There are extensive appendices which have not really been studied with interviews and surveys of lending arms, banks, insurance companies, etc. It's a treasure trove of information as well. The equivalent of email in the 30s, sort of correspondence, and then the map itself. So there's a very simple page-turning interface. You can actually read this as a book, step through the collection, look at all the content. So what I did here is I picked a particular file under area description. And area description is really the core of the collection. It's essentially a template, sort of database ready in the 30s, but a template with all these different attributes and characteristics of the neighborhood. So you have population characteristics, housing trends, class and occupation summaries, percentages of foreign families, nationalities. So this particular area describes Mexicans, Japanese, and Italians, a special category for African Americans or Negroes, you have percentage of Negro, and then characteristics of desirability, which are most often linked to race. Slow increase of subversive races. And if you were to scroll down this form, you have all kinds of information on buildings, rental market, construction, so average age, sales, rental, and if you go all the way down, you have very intricate sort of free text descriptions with a lot more context. And in those sections, you will have sort of the rationale for why these forms were put together. Depending on the city, you might even have sort of the appraiser, the people, there's provenance on who compiled this, who assembled it, what their backgrounds were, etc. Very often in the descriptive text section, you will find very specific descriptions of there are 2 Japanese families living on this corner, or there is 1 black family by this, in this particular part of that neighborhood, etc. So this is where incorporating or doing mashups with the 1940 census, 1930, 1940, which frames this particular slice of history, would be extremely powerful. And I haven't done that yet, but so this mimics some of what Peter did. I'll just take a couple of simple examples. How am I doing on time?
You're getting along.
Okay. So we took one of these area description forms. Unlike the obesity study Peter talked about, we don't have a template. This is a typewritten page. Turns out that you have a fixed part. Those are these green boxes. And then you have a variable part that was typed in for each of the neighborhoods. So what we essentially did is we drew a template on top of this hybrid form to recognize, so we recreated the template. We could have tried to derive it automatically. And then we used this fixed part to actually identify all the variable sections. So we have a mask. It's this template-based approach. And you can OCR, you scan this, OCR it, and automatically extract the values in all these different fields. So you have a very segmented, faceted framework. We clean these. It's a lot easier to clean because we have clear boundaries and we know where these sections start and end. And we load these into a database. So I'm going to show you a couple of screen snapshots with some of the capabilities. So we essentially started from the original paper documents, scanned them. So created, in this particular instance, our images are PDF documents. You can turn pages between those. We also scanned, OCR'd, parsed the documents, put them in a database, kind of sketched how we did that on a very simple example. And then the third facet is we took not just the surveys, but the redlining maps themselves, which are images, of course, and we did the equivalent of OCR. So we vectorized those maps, recognized all the individual boundaries of the neighborhoods, and created clickable segmented maps that you can then link to individual boundary files. So it's both vectorization of the maps and kind of vectorization, segmentation of the text. So I'll show you what these beautiful maps look like. And there's 8 cities, so I'll flip through them very quickly. This is San Diego. On the left, you have the original map. You kind of see the color code. Green were the primarily Caucasian-only areas. Blue were near Caucasian, but built up. Red are the redlining areas, and that's where the term comes from. And there's a whole framework that describes how the color code was established, what its meaning is, etc. So for each of these maps, we essentially created a Google map version where each little boundary is a map or maplet of itself. It's individually clickable, and we're linking all these little areas, geographical areas, to segments of the text, and we've created indexes, etc. This is in the text, a direct quote. You'll see what redline is: detrimental influences, undesirable population, infiltration of it, etc. So there's a very rich literature. It's this whole epidemiology theme of containment of groups and races and protection of property and ethnicity and property, of course, are intimately linked. This is FRESNO. This is San Francisco, Oakland, Berkeley, San Jose, Sacramento, Stockton, and I'm going to finish with a few clicks on the Los Angeles map. So this is LA, and oops, there we go. LA was actually, it's the more interesting city. It's 4 maps in one. By the time we're done vectorizing these maps, georeferencing them, vectorizing them, we have over 400 individual polygons, clickable polygons, that are in this area. So where do we go from here? So I'll do a couple of walkthroughs with some simple functionality. So in the case of Los Angeles, on the left, you can we've color-coded everything. So you can turn on, turn off entire colors, open these up, and you'll have individual neighborhoods. Click on the names of the neighborhood, and they'll be highlighted on the map. And then there's a very simple toolbox here where we experimented with a few interfaces. This is just a start. So back to that image I showed you of the hybrid form with the typewritten text. What we actually decided to do, because it mimicked the process of extraction of the content, was have an interface where you're presented with the scrubbed historic form. I'm wondering, I don't know if it's been done for 1940 census information, but I'm wondering if similar interfaces could actually be proposed, where you would have a blank 1940 form. You could click on individual fields and explore and analyze all the content, staying close to the original historic documents, and use it sort of as an exploratory visual analytics approach. And this is kind of what we do here. So I'm speculating that there might be some correlations with possible 1940 census interfaces. If I go to Tools and I select Field Query, I get a blank form. There's a little AJAX interface on the web, so I can go in a very surgical way, pick individual fields. What comes up dynamically is the database is queried, and you have a pull-down list that's populated on the fly, and you have the range of all the values across all 400 polygons for the entire city. So think of similar interfaces for the 1940 census, where you could select a column, a name, and depending on the context, say I want to see the range of values for ethnicity or employment for a particular ED area or a larger area or combinations. So there's suggestions of interesting, maybe innovative interfaces. So if you look at the pull-down values here, this is typical. Under nationalities, now you have a bird's eye view of the whole city. No subversive races known, one Mexican family only. Think about connecting that with Census 1940 or 1930. Orientals and Mexicans, so this is equal opportunity of discrimination, everyone gets it. Polish, Russian, and Armenian Jews, possibly a few Mexicans. Russian, Polish, Armenian Jews, Mexicans, Italians, Greeks. Russians, Greeks, and Mexicans, scattered Mexicans, Serbs and Italians, very few subversive, on and on. So it's the United Nations of discrimination. And you can pick multiple fields, and in this form do Boolean sort of queries. So here I could pick, show me, I'm interested in areas where one Mexican family is mentioned, and where you have 1% Negro. And then you'd go back, and what happens is your map is subsetted on the fly, and you have only those areas where those conditions are true. And you could query on combinations of the built environment, ethnicity, race, employment, all kinds of other factors. So it's kind of a form of, I don't know what to call it, historical, ethnic mashups, if you will. So this shows you where we landed, and then you can click on that, further refine it. This subsets and shows you only those neighborhoods in those areas. If I were to then click on D10, what I come up with is an index. In this case, they're a little hard-coded, but we would like to create these dynamically. And what this shows you is the occurrence of a reference to D10 in the collection itself, and it clusters it by type of document. So it essentially says that D10, well, obviously it's in the map. It's not explicitly mentioned in the correspondence. It is in the report, it is in the area descriptions. And then we also have kind of RDF, sort of semantic relationships. D10 is also part of Pasadena. So we're showing you all the connections and indices for the occurrences of Pasadena in the collection. So from that initial search of one Mexican family or 1% Negro presence, you're thrown into a subset of the map, and then you can visually explore the documents in a guided way. Okay, I'm going to stop here. And then the last interface from Tools is a text interface. So if you don't want to use that form, you can use a standard keyword approach. So this is a particular one for each city. I suggest sort of egregious ethnic queries you might run. So you could look at zoning, presence of zoning and restriction, foreclosure, detrimental threats, presence of Japanese, Orientals. This is a particular query where I'm saying, take the full map of Los Angeles, show me all the neighborhoods where Jews are mentioned, but not Jews related to the motion picture industry. And the map comes back with a subset, and then you could further explore that and jump around, etc. So I'm going to stop, and that's one of the areas. So you see where the word Jew was picked up. Under shifting or infiltration, you have slight infiltration of Jewish people and all kinds of other considerations. So I'm going to show you one more slide, and we'll stop here. This was an earlier study done with San Diego, where I actually worked with demographers, and we used 1990 and 2000 census information. So think of the value of being able to go back in time and frame this period. So this was a tale of two neighborhoods. We took Mission Hills by Old Town, which was a green area, that's where I used to live, and Logan Heights, which was a redlined area. And these are the descriptions used in the historical text. And if you follow the evolution, it's not much of a trend because we just have a few data points, but we normalized the information, created our own index. If you follow these trends, Mission Hills between 1990 and 2000 only got greener, and Barrio Logan only got redder. And my initial research interest in this project was really to look at, well, infrastructure, because that's my background, but bring in these notions of race and space and look at the urban landscape. And the main research question was, what is the persistence of these historic factors in the present? And how can we use a combination of qualitative methods and other approaches to actually analyze this in a much more consistent, dare I say, scientific fashion. And so this was the beginning of our project. The last interface, and I'll end here, and you could go on and on. This was just a sampling of interfaces. You can automatically download any of these redlining maps as an XML file, a KML file, into a completely different environment, sort of take it out there. This is Google Earth. And I'm overlaying that with the urban landscape of Los Angeles in 2000, so you have skyscrapers, et cetera. And it suggests this notion of essentially historical layers and mashups and being able to mix all these different layers in contexts that you've been talking about today and that we're going to get into. And so this is just one layer with some visual analytics. This would greatly benefit from the census information, but possibly some of the methodologies and approaches might be applicable as well. So thank you very much.
I'd like to thank the speakers for staying pretty much on time, but I encourage you, on the off chance you'd actually like something to eat, to take the conversation time over lunch instead. Thank you very, very much.